Today we're going to talk about another method for solving systems of linear equations called the elimination method. You can find more details in your textbook, which is also available online, and many of you have a physical copy. To solve a system of equations using the elimination method, follow these steps. Step 1. Write both equations in standard form. This means collecting all the variable terms, x and y, on one side and placing the constant number on the right side. If any coefficients are fractions, clear them by multiplying the entire equation by the least common multiple, LCM. For example, if you have fractions like 1/2 and 1/3 in the same equation, you can multiply everything by 6, the LCM of 2 and 3, to eliminate the fractions. Step 2. Make the coefficients of one variable opposite. Decide which variable you want to eliminate, either x or y. For example, if one equation has 3x and the other has 2x, they are not opposites, but we want to make them opposites. To do this, multiply one or both equations so that the coefficients of that variable are opposites. For example, multiply the first equation by 2 and the second equation by -3 to make the coefficients of x be 6x and -6x. Once the coefficients are opposite, we can eliminate one variable. Step 3. Add the two equations. By adding the equations, one variable will cancel out, leaving you with an equation in only one variable, either x or y. Solve this equation for the remaining variable. Step 4. Substitute the solution from step 3 into either of the original equations to solve for the other variable. Step 5. Write the solution as an ordered pair, x, y, just like in the substitution method. Step 6. Check the solution by substituting the values of x and y into both of the original equations to ensure they work for both. Let's apply the elimination method to example 8. We're given the following system of equations. -2x 5y equals 11 and 4x minus 3y equals 15. Step 1. Both equations are already in standard form, so we can skip this step. The standard form is ax plus by equals c, and both equations match this format. Step 2. Now we need to make the coefficients of one variable opposite. Let's eliminate x by making the coefficients of x opposite. We have -2x in the first equation and 4x in the second equation. Since 4 is a multiple of 2, we can multiply the first equation by 2 to make the coefficient of x -4x. So, multiply the first equation by 2 times. -2x plus 5y equals -11 becomes -4x plus 10y equals -22. Step 3. Add the equation to an equation from step 2, or called equation 3. -4x plus 10y plus 4x minus 3y equals -22 plus 15. The x terms cancel out. 10y minus 3y equals -7. 7y equals -7. Step 4. Solve for y by dividing both sides by 7. Y equals -1. Step 5. Now substitute y equals -1 into one of the original equations to solve for x. Let's use the first equation. -2x plus 5y equals -11. Substitute y equals -1. -2x plus 5 times -1 equals -11. -2x minus 5 equals -11. Add 5 to both sides. -2x equals -6. Now divide by -2. X equals 3. Step 6. Write the solution as an ordered pair. xy equals 3, -1. Finally, we should check the solution by plugging x equals 3 and y equals -1 into both of the original equations to ensure that the solution is correct. That's the complete process for solving a system of linear equations using the elimination method. Remember to check your solution using the original equations, as mistakes can happen if equations are modified incorrectly.